Welcome to Chemistry Clips. You are watching Amines Part 2. At the end of this clip, you should be able to explain the basicity of amines and provide mechanisms for the common reactions that amines undergo. You should be familiar with the processes involved in the synthesis of amines, which were discussed in the first clip. In this clip, we will be going through the following: the basicity of amines, the reactions of amines with acids, the acylation of amines, and the reactions of amines with aldehydes and ketones. Amines have both basic and nucleophilic properties. This is because of the lone pair of electrons situated on the nitrogen atom. This lone pair enables the amine to react with acids to form acid salts and to react with electrophiles. The basicity of an amine is measured by the acid dissociation constant of the amine's conjugated acid. If the conjugated acid has a small pK value, then the amine is a weak base. However, if the amine's conjugated acid has a large pK value, then the amine is a strong base. The following table shows a range of amine basicities. As you can see, alkyl amines have a slight difference in their pK values, therefore they have similar base strengths. Whereas aryl amines and heterocyclic amines are less basic than alkyl amines. You can see this by comparing the pK values of the ammonium ions. The reason why aryl amines are less basic than alkyl amines is because of the delocalization of the nitrogen lone pair. In alkyl amines, the lone pair of electrons on the nitrogen atom are localized, making the molecule more basic. When an amine reacts with an acid, the nitrogen atom donates a pair of electrons which neutralizes the acid and forms ammonium salts. When primary or secondary amines react with a carboxylic acid, ammonium salts are formed. However, they can be thermally dehydrated to form the corresponding amines. A way to remember this concept is to think of the reaction that occurs when lemon or vinegar is used on fish. Both lemon and vinegar are acidic. Therefore, when added to fish, the acid neutralizes the amines in the fish, which reduces the smell of the amines. Acylation is the process in which an acyl group is added or substituted into a compound. Acyl halides, otherwise known as the acid halide, are extremely reactive. The X in the diagram represents a halogen atom. Acyl halides undergo nucleophilic substitution. This is because of the carbon atom. It has an oxygen atom and a halide atom attached to it. Both of these atoms are very electronegative, making the carbon atom more positive. Therefore, the carbon atom undergoes nucleophilic attack. Only primary and secondary amines can be acylated by nucleophilic acyl substitution. Tertiary amines do not undergo this reaction because tertiary amines are not bonded to any hydrogen atoms. Acyl halides can only replace a hydrogen atom bonded to a nitrogen atom. It cannot replace an alkyl group. These are the general equations for this reaction. The nitrogen atom in the amines acts as a nucleophile, attacking the carbon atom, resulting to the halide being kicked out of the molecule.
Aldehydes and ketones react with amines to form highly substituted amines in a reaction called reductive amination. Here the R group can be either a hydrogen atom, i.e. for aldehydes, or an alkyl group for ketones. The key thing is that they both react the same way. If an aldehyde or a ketone reacts with ammonia, it forms a primary amine via an imine intermediate. If it reacts with a primary amine, it forms a secondary amine, also via an imine intermediate, while the reaction with a secondary amine proceeds via an enamine intermediate to give a tertiary amine. Reductive amination is limited to primary and secondary amines, as there must be at least one hydrogen atom for deprotonation to occur. Now let's look at the mechanism. Here we're looking at the reaction of propanol with methylamine. The reaction is catalyzed by acid. In the first step, protonation of the oxygen atom occurs to make the carbon of the carbonyl more susceptible to nucleophilic attack. The nitrogen lone pair of methylamine attacks the carbon, breaking the carbon-oxygen double bond. The cationic intermediate is then deprotonated to give a carbanolamine. In the next step, the alcohol of the carbonylamine is protonated to make it a better leaving group. The lone pair of nitrogen then forms a pi bond with carbon, ejecting water to give an aminium cation. A hydride ion from sodium borohydride then adds to the carbon of the aminium to give N-methylaminopropane. In this series of clips, we have covered the key methods of synthesizing amines from organic starting material, as well as the common reactions of amines. Here is a recap of these reactions. We first looked at the conversion of alkyl halides to amines. We saw that the reaction of alkyl halides with ammonia and amines is not a viable lab method, as it generates a mixture of products. The Gabriel-amine synthesis and the conversion and subsequent reduction of nitriles and azides were found to be much cleaner methods, generating primary amines exclusively. We also looked at the reduction of amides and the Hofmann rearrangement. These reactions both start with an amide and produce a primary amine. However, the Hofmann rearrangement gives a product with one carbon atom less than the starting amide. The Curtius rearrangement also gives a primary amine with one carbon less than the starting acyl azide. In this clip, we looked at reductive amination, a good method of generating amines from aldehydes and ketones, and then we looked at the reaction of amines with acids in acyl halides. You should familiarize yourself with the reagents used in all these reactions. At the end of this clip, you should now have a good understanding of the chemistry of amines and be able to outline the common reactions of amines. You should also be able to draw mechanisms for the conversion of alkyl halides and other carbonyl compounds to amines. Finally, you should be able to predict the pKa of a given amine and account for the differences in the pKa values of alkyl, aryl, and heterocyclic amines. Thank you for watching Chemistry.